us, and welcome to our first official lesson of trigonomic functions. I know that you did a little quick review last class probably, but this is our first official lesson, so you'll have some homework with this as well. So we're taking a look at trigonomic ratios of acute angles, okay? So we're just going to do a quick review to make sure everybody is good with some basic knowledge from trigonometry, but then on the next page I'm going to teach you some new stuff as well that we added on. Just remember that for the first part it says labeling conventions. If we have capitals for our angles A, B, and C, I apologize. I will go, let me just change it so it matches the ones that'll be on the answer key. So we'll go A, B, and C. And just remember these side lengths that are opposite it are in lowercase letters. So lower C, lower A, and lower B. Also take note, folks, that normally we're used to theta as being one of our angles, but for angles in our textbook, you're going to see a whole bunch of Greek letters. You're going to see you can see alpha, you can see beta, they have a gamma. Okay, so these are just Greek letters that just represent a value. So please don't get caught up on that. They just extend those. All right, topic number 2, Pythagorean theorem. Again, Pythagorean theorem is used when you have what's called a 90-degree triangle. And we know that the longest side of a 90-degree triangle is C, the hypotenuse. Call hype for short. And it is the longest side. You should remember that from grade 9. And the other two sides, it doesn't really matter which one you call them. But just remember that your formula is C squared equals A squared plus B squared. When do you use Pythagorean theorem? When you're given two side lengths and you need to find the third of a right triangle. Okay? Next, we're going to deal with, again, right triangle, but we're going to take a look at what we call the primary trig ratios. Okay? And it depends on your angle of reference. So if I start here with an angle of reference, okay, across from that is my opposite side. Closest to it near the 90 is my adjacent side. And the diagonal that's the longest side is your hypotenuse. Just remember to use what we call SOHCAHTOA to help us with these. So our three trig ratios are the first one, which is sine. So sine theta equals the length of the opposite side divided by the length of the hypotenuse side. The next trio is the cosine. So cos of theta equals the adjacent side over the hypotenuse side. And the last one is the TOA. That's the tangent of any angle, compares the opposite side to its adjacent side. All right? Good. So those are your three primary trig ratios. We're going to add three more to it on the second page. Okay? Example 1. Find the measure of theta in each case. All right, let's take a look here. So if I say theta is here, that's my theta. And let's say that I have 3 meters here and 7 meters here. All right, so from my theta, which I'll put in a different color because it's hard to tell. So from theta, what two sides do I have, folks? I have my adjacent side, because this is my 90, and this is my hypotenuse side. Okay, so taking a look at that, we realize using SOHCAHTOA which one has the adjacent and hypotenuse together. That is the cos. So cos theta, we can sub it in right away, is the adjacent side, which is 3, over the hypotenuse, which is 7. To get that angle, remember you do the cos inverse. 3 over 7. So theta here, if we go to the nearest degrees, folks, is 65 degrees. Taking a look at our second triangle, there's our 90 degree, ladies and gentlemen. Let's say we have 2 centimeters here, and we have 5.5 centimeters on the diagonal, and we want to find that theta angle right there. According to that angle, we have the opposite side, guys, and we have the hypotenuse. What ratio has the O and the H in it? That's going to be sine. So sine theta equals 2, which is your opposite side, over 5.5, which is your hypotenuse. Opposite over the hypotenuse. Again, to find the angle, it's going to be the sine inverse of this fraction. Plug it in your calculator, ladies and gentlemen. You should get 21 degrees. All right. Okay. Find the measure of each side length. All right. So here's my 90 degrees. And let's say this is 31 degrees, this angle. And I'll say we're going to find A here. And we'll give another measurement of 15 centimeters. So looking at our angle of reference, which is 31 degrees, across here is the opposite side, and this is our adjacent side. What ratio has O and A in it? It's tangent. So you go tan of 31 degrees, you can sub it right in now, equals the opposite side, which is A, over 15. A is on top, so it's an easy cross multiply. So A equals 15 times tan of 31. Plug it in your calculator, and that's going to be 9.0 centimeters. All right, next one. Let's take a look at the 90 degree being here. Let's say that this is 49 degrees angle there. This is A we're trying to find on the diagonal, and we'll say this bottom measurement is 6.7 meters. Okay, so from the angle that's given, what's 6.7? That's the adjacent side. And A is your hypotenuse. Okay, so taking a look, what ratio do we have, ladies and gentlemen, that has A and H in it? That's cosine. So cos of 49 degrees equals 6.7 over A. Last day we learned a quick switch. When the variable's on the bottom, we do what's called a switch. So it's going to be A equals 6.7 divided by the cos of 49 degrees. And I apologize, I forgot my degree sign up there. All right, and plug it in your calculator, and you should get 10.2 meters. All right, to solve this triangle, ladies and gentlemen, I don't have enough room on your page, so we're just going to ignore the first triangle and just deal with one of them. Okay, but what we need to do is remember, what does solve mean, folks? Solve means to find all missing angles and sides. Okay, so let's take a look at what I'm going to give you for some information. Here's my 90 degree triangle. I will say this is 1.5 meters and 2.8 meters. And just for simplicity's sake, folks, let's just label these A, B, and C. Okay, so when we need to solve this triangle, what do we need to find? We need to find side C, so we need my fault. Let me just erase that. Okay, so we need to find several things. We need to find side C. We need to find angle A. And we need to find angle B. Okay, first thing I would notice is to find side C. So to find C, which is that, okay, I'm going to use Pythagorean theorem. So C squared equals 1.5 squared plus 2.8 squared. And use your calculator, figure that out. C equals 3.2 meters. Don't forget to take the square root after you've added the sum of those squares. Okay, that's the best way to find side C. It's the most accurate. Okay, let's find angle A. To find angle A, I'm going to use the tan ratio because I've got the opposite and the adjacent sides. So tan of A equals 1.5 divided by 2.8. To find the angle, remember you've got to find use the inverse. So it's the tan inverse of 1.5 divided by 2.8. Plug that in your calculator, ladies and gentlemen, and you'll get 28 degrees. Now, to find angle B, Hopefully you remember a shortcut in this case. Angle B equals 180 degrees. Subtract 90, which is the right angle. Subtract angle A that we already know, which is 28 degrees. Angle B equals 62 degrees. Now, I will let you know, folks, if you take a different approach here, for example, say you use, to find C, you use angle A, and then maybe either use the cosine or the sine ratios to help C. Just remember, if you've rounded an angle, that's going to affect you finding the side C. So I'd always use the best approach to find side C is using with the accurate information that's given. For example, if you use the trig ratios from angle A or B to find side C, you will have rounded and it may not be as accurate. Okay? All right, on to some new stuff. Are you ready? Here we go. New. Sometimes these are called secondary trig ratios, but sometimes they say there are 6 primary trig ratios. But we'll call them secondary trig ratios for now. And they are called the cosecant, secant, and cotangent. And they are the reciprocals of the primary trig ratios. So for example, cosecant has a short form, CSC, theta, equals, and that's the reciprocal or the inverse of the sine ratio. So what does that equal? Instead of opposite over hypotenuse, it's going to be hypotenuse over opposite. Okay. The second ratio is called secant, and it is the inverse of the cos theta. So instead of having adjacent over hypotenuse, it's going to be hypotenuse over adjacent. And the last one, which is the cotangent, that's easy because cotangent tells us that it's the opposite of the tangent ratio. So instead of opposite over adjacent, it's going to be adjacent over the opposite. Okay. Let's take a look here. Given example 4, given triangle ABC, state the 6 trig ratios for A. Well, first of all, let me label it. So we'll go A, B, and C. And the dimensions I will give you is 5, 3, and 4, like that. Okay. Now it says for angle A, which is good. So this is our angle of reference. So sine of A, folks, equals the opposite over the hypotenuse. So that's going to be 3 over 5. We'll do the primary ones first. So cos of A is going to be the adjacent over the hypotenuse. So that's going to be 4 over 5. And the tan is going to be opposite over adjacent, which is going to be 3 over 4. Now, when we go to do the secondary ones, just remember cosecant is the opposite or the reciprocal of the sine. So instead of 3 over 5, it's going to be 5 over 3. And the reciprocal for cos theta is cosecant. Sorry, is the secant, my fault, said that wrong. And so you invert or take the reciprocal of the fraction of the cos A. Okay, so 5 over 4. And the last one, cotangent. Again, flip the fraction, so it's going to be 4 over 3. All right, almost done. Now we're going to learn how to evaluate using our calculator. Notice, ladies and gentlemen, that these short forms, cosecant, cotangent, and secant, aren't buttons on your calculator. So you have to know which reciprocal it matches. Okay? Once you know that, then you can figure this out. So for example, cosecant is the reciprocal of sine. So it's going to be 1 over sine of 35 degrees. And just plug it in your calculator, ladies and gentlemen, and it equals approximately 1.7. All right. Cotangent of 57 degrees. Again, cotangent is the inverse of tan, so it's going to be 1 over tan 57 degrees. Okay, plug in your calculator and you get approximately 0.6. Now, one thing I will add here, for example, C, What if I have, for example, I bring this one down here and I say cot A equals 4/3. Okay. Again, we can't, to find that angle A, we can't plug cot A in because there's no cotangents. But what we do know is that it's the reciprocal of the tangent A. So if we go tangent A, then we make it 3/4. And then to find the angle, remember to use your tan inverse button. So the angle A here for that case would be approximately 37 degrees. All right, ladies and gentlemen, let's take a look at some homework. So page 280, numbers 1 to 7, give 9 and 18 a try. And again, come see me if you have any other questions or need some help. Have a great day.